All right, so finding all the solutions to the equations. So these are all in factored form. Okay, that means that they have parentheses and they're all broken down, right? Okay, so to find the solution, all you're going to do is set this guy equal to 0. And then now we're going to solve. So we're going to subtract 2. And that means that we're going to have x equals -2. We're going to do the same thing for this next one. We're going to say x minus 5 equal to 0. When we solve, we'll get x equals 5. On the next one, we set this equal to 0 and we solve, we're going to get x equals 3.
It does have to eventually all equal to 0. So therefore.
Yeah. Yeah. Okay. And then on this last one, we're going to add 5 to both sides, divide by 2. So it's going to give me 5 halves. I know I did that pretty quickly, but I feel like at this point, you probably got it. So our solutions are x equals 5 halves, x equals 3, x equals -4, x equals 5, x equals -2.
We should always do it in fraction.
Yeah, you can leave it in fraction form because that's probably what your answer choices are going to be. If you understand what you're doing, go ahead and do B, C, and D. Okay, if you already know what you're doing, after that, go ahead and try B, C, and D. So I added 5 to the other side and then divided by 2.
Right. Okay.
Yeah, it's like how you normally solve stuff. Yes, you gotta. Yeah. So the final answer is x equals -4, 3, 5, -2, and 5 halves. Right. Okay, go ahead and try B, go ahead and try C, and go ahead and try D. Take a second, try those. Okay, so on this next one, you're going to take each one of these and set it equal to 0. So you'll have 2x minus 3 equal to 0. So what's the first thing I'm going to do? Add 3 to both sides. Sorry, I did the second one first. Yeah. And then what? Divide by 3 on, or divide by 2 on both sides. So that's going to give me x equals 3 halves. We're going to do the same thing with the 2x plus 3. So 2x plus 3, we're going to set it equal to 0 when we solve. And then we're going to divide by 2. So x is going to equal -3 halves. I would just ask, how do you write this out as the answer? You literally say x equals -3 halves and x equals 3 halves. Like that's how you would write it. Ta-da! I know. Yep, literally. I know, I just worked there. Okay, I'm going to do D first, and then I'll go back to C. Okay, so on D, you're going to set it equal to 0. And then you're going to solve. So you'll subtract 5. You're going to divide by 2. So x is going to be -5 halves. And x is going to be -1. Because you'll just switch the sign of this guy. Why?
Like quick math and just like.
Yes. 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 Normally you could probably do this in your head. Yes. Like move 5 over. That's gonna be a -5. Divide by 2. You always flip the sign of whatever that is. Yes. Not now, but do. Okay. C is the one that's probably gonna give people the most trouble. So let's talk through this one. This 3x, you're gonna set it equal to 0. This x squared plus 2 equal to 0. And that's x plus 5 equal to 0. Now, over here, we're going to divide by 3 on both sides. So x is going to equal 0. Okay, simple enough. For this x plus 5, we're just going to switch the sign. So x is going to equal -5. For this one, okay, we're going to subtract 2 from both sides. And then we're going to take the square root. When we take the square root of a negative number, what do we get? Have we talked about this yet?
No.
I don't think so. Okay. We get an imaginary number. We did talk about that. Okay. So we're going to have positive and negative I square root of 2. So we'll have x equals -5, x equals 0, and x equals positive and negative I square root of 2.
Oh, that's what the I meant.
Of like all things algebra. This is it. This is like our Super Bowl. Okay. Fundamental theorem of algebra. That is what you're going to title this page. Okay. And here is what it is. The degree of a function is equal to the total number of solutions of a function as long as duplicates are counted as separate solutions. I want you to take a moment. I want you to write that down. I'm going to explain what all that means. It's really not that difficult. It's really fundamental theorem of algebra. Okay, so when we say like fundamental theorem, that means like that is the foundation for all basis for algebra. Okay, that's where it all comes from. So when we say that something is a theorem, we say that because it has been proven over multiple times. Okay, yeah. So when we say fundamental theorem, it's like this always works. This is always the case. Okay.
So what is it not that?
I mean, it's kind of like math people saying facts, big facts, yo.
Oh.
Big facts of the algebra. I just work here. Listen, it's fine. Great heavens. Easy. Okay, we're writing down this first one. So we're focusing on this. Doing math. We're doing math. Okay. So when I solve all this mess out, this is I think this is the first one that we did. This is A from the activating strategy, right? So our solutions were -2, 5, 3, -4, and 5 halves, right?
Yeah.
Okay, so we're gonna graph all those bad boys on this x-axis. So we got -2, 5, 3, -4, and 5 halves is 2.5. Yeah. Okay, so it's gonna be like right here, right? Okay. Now, degree. We can tell what the degree is by the number of solutions that something has. Okay, so how many solutions do we have? 1, 2, 3, 4, 5. So the degree is going to be 5.
Wait.
Now, we can sketch the graph. We know that this is going to be a positive function. The reason why is because if you look at all these x's, and if you multiplied all of these together, it would be a positive x to the 5th, right? Yes? Okay, so it would be facing upwards. So watch what's going to happen. We can see that at the 5th degree polynomial, which last week we talked about the fact that anything with an odd is going to look like this. Like that's roughly what it's going to look like. So we can connect all these dots. And that's the sketch that it's going to look like. So now let's look at the next one. This is C. Our solutions to this were 0, positive and negative I square root of 2, and -5, right? Okay, we're going to have an x-intercept at 0, -5, and then we can't graph this I square root of 2. Imaginaries do not cross the x-axis. Okay, I'm going to say that again. Imaginaries do not cross the x-axis. Imaginary solutions do not cross the x-axis. So you're not going to see them, but they are a solution. So how many solutions do we have in total up here? Okay, so imaginaries do count. And we have 1, 2, 3, because remember, we got a positive and a negative. 4. So this is a 4th degree polynomial. Okay. I'm going to say it again for the people in the back. We got 1, 2, which is positive, 3, 4 solutions. Imaginary solutions always come in pairs. Okay, there's always a positive version and a negative version. Okay,
So they count as 2 solutions.
they count as 2 solutions. Okay, now this is a 4th degree polynomial. We learned, that last week a 4th degree polynomial looks like a W. Okay, so our sketch is going to look like that. Now, again, with your sketch, it's not going to be exact. It's just showing me how the end behavior is going. Okay. Cool.
Do we have every degree memorized?
So if I have x to the first power, what does that look like? No, x to the first power. I have like x plus 3. That's going to be like a straight line, right? Okay, if I have x to the second power, that's going to give me like that U shape, right? If I have x to the third, we already talked about it, it's going to be like that squiggle. If I have x to the fourth, it's going to be a W. If I have x to the fifth, it's going to be a squiggle. If I have x to the sixth, it's going to be a W. If I have x to the seventh, you see it? Okay, now it's going to look varying depending on the number of solutions, as well as if there's a stretch, that kind of thing. But roughly the shape is those two things. And then find and graph the zeros. All right. Now we've got something a little weird. It's not in factored form this time. Okay, so we can't just set it equal to 0 and then solve. We've got to take out the greatest common factor. Okay, so from 4x to the fourth and 12x cubed, let's just look at the numbers. 4 can be taken out for sure. And then from here, we've got 4 x's and we got 3 x's. How many can I take from each group evenly? 3. So I can take out x to the third. Okay. Now, when I take 4x to the fourth and I divide it by 4x to the third, how many x's am I going to have left over? Okay. When I take 12x to the third and I divide it by 4x to the third, how many x's am I going to be left over with? None, but what's 12 divided by 4? Okay. So I get 4x to the third times x plus 3. Okay, so I said 4 and 12, what can I take out from both of those? A 4. From each one of these x to the fourth and x to the third, how many x's can I take out? That's going to be the same from each. So 3. So I would put x to the third. So now when I take 4x to the fourth and divide it by 4x to the third, I'm going to have x left over. 12x to the third divided by 4x to the third is going to be 3. Yes.
Wait, so the second number, you take out like the actual number, and like the first number you take out for x's.
Yeah. You just take out the greatest common factor. That's what we did here. We took each one of these and we said the greatest common factor is 4x to the third. I'm going to divide each one of these by this. And I was left over with x plus 3 up at the top. Okay, now it's in factored form. So now that it's in factored form, we're going to do the same thing that we did earlier. We're going to set each one of these equal to 0 and solve. So take a moment, find what the zeros are, and we're going to talk about it in just a second. If we solve this x plus 3, what will we get? X equals, okay, so we get x equals -3 for one of them. So let's go ahead and graph that guy. Then if we take 4x to the third and set it equal to 0, a lot of people freak out about this exponent. The first thing we would do is divide by 4. And then in order to get rid of that cubic, we're going to take the cubic root.
Oh my God.
Welcome to algebra 2. Okay, so that's going to be x equals 0.
What?
That's it.
I could skip that part, you know.
If you take the square root, the cubic root of 0, it's going to give you 0. You take the 16th root, 0. Now my question to you, what degree is this guy? Well, since we had it in the original standard form, look at what the, girl, look at the highest exponent. It's a 4. Okay, so our degree is going to be 4. Okay, now all of y'all are going, that doesn't make sense because, okay, we're getting there. We're getting there. Okay, so look at the degree. The highest degree is 4. Now, you remember back in the fundamental theorem, how it said, I'm gonna clear this really
As long as
quick.
duplicates are counted as separate solutions.
There you go. As long as duplicates are counted as separate solutions. So coming back to our work, you notice how there was an x to the third? That's a duplicate. That means that we're going to have x equals 0 3 times. Okay, but we're not going to graph that 3 times. Okay, so let me show you what's going to happen. When we graph this, we're going to have a W, right? So this guy is going to come down, cross, and then wiggle through this guy to go back up. So this right here, this little like wiggle represents that we have a duplicate of 3 times. Okay. On this next one, okay, there's 2 different ways. There are 2 different ways to do this. You can either take out the greatest common factor. Okay. You can either take out the greatest common factor, which from this 2x squared and this negative 50 is going to be 2. Okay. Now we can factor this. Y'all have seen this as a perfect square. So this is the difference of perfect squares, right? So you learned this a couple weeks ago. I know it's been a minute, but this would be x plus 5 and x minus 5. Okay. Okay, I don't look, no crazy looks, so we be okay on this? Okay, so when we solve, we're gonna get x equals negative 5 and x equals 5. Please do not set 2 equal to 0 and then say x equals 0. Don't do that. Okay, so this is our answers. Okay, so don't set 2 equal to 0 and solve, because there's nothing to solve. 2 equals 0 is not a thing. Okay, so we're gonna graph that. Listen, I've seen it. Okay, now what's my degree? 2. And so this guy is gonna look like a parabola. Boop. Done. All right, so I'm gonna go ahead and work number 4, and then we can come back to 3 if we got a second. So on number 4, we factor. A times C is gonna give me 6. B is is 5, negative 5. What 2 numbers can I multiply together to get me 6, but add together to get me negative 5? Negative 3 and negative 2. So if I write this out in factored form, I would have x minus 3, x minus 2. If I solved, I would get x equals 3 and 2. Degree is 2, so we're going to have a parabola. Okay. Now this is where factoring came back into play. You have to know how to factor from here on out in your mathematical career. Okay, so please make sure that you know how to do this. If you don't, you got some homework. Okay. On this one, we can do something very similar. We can go ahead and take out an x. And then we can factor. So we can say A times C is 160, B is 26. So what 2 numbers can I multiply together to get me 160, but add together to get me 26? No, that's 12. That's 120. $16 and $10. You just needed an extra second. It's okay. All right, so the only problem is on this one, we've got an A term that's bigger than 1. So I use the slip and slide method. If you want to use the box method, that's okay. But we would get x plus 4 on this side. On this side, I would get 2x plus 5. But when I solved all this out, and again, I know I'm going pretty fast on this, I would get x equals negative 4, x equals negative 5 halves. And then x equals 0 because we took out that x at the beginning. So since it's a cube, it would look like